احنا موضوعنا اليوم نكمل في الeffective stress concept. Effective stress concept. This is the revolution of Terzaghi, the father of soil mechanics, who said that we should deal with effective stress, not with total stress. Total stress consists of two components: stress held by soil only and stress held by water only. So sigma total equals to sigma effective, sigma prime, okay, plus pure water pressure. So effective stress is the difference between the total and the pure water pressure. Always we have to subtract pure water pressure from total stress to get effective stress. Effective stress is the most important. This is what we are looking for. From now on we will be dealing with effective stress. But let us also prove it. Okay? Let us prove that Terzaghi was correct. Okay? So we go here. You know this. Okay? Effective stress equals to the height of submerged soil. Okay? Height of submerged soil. This is soil. Height of submerged soil multiplied by gamma effective or gamma prime. Gamma effective or gamma prime is gamma saturated minus gamma water. You should remember this, okay? You don't need to make any mistakes here. Okay. Now, let us prove Terzaghi's idea. We said that we will take three conditions. One condition is this one, which is no seepage condition. No seepage. No seepage. No water flow. So as you see here, we have, this is water, and this is soil, okay? And then we have a valve here. It is closed. This is H1, this is H2, and this is Z, okay? And we need to study to understand how things will be in the soil. Let us take some points, okay? Usually in this case we take points in the borders because the change between borders is linear, okay? So what we need is to take just these points. Point A, okay? Point B, because the change between A and B is linear, okay? Because there is only just water. The only difference here is not in unit weight, but it's in the height, right? So it's linear. A, B. Let us take point C. What is C? Any point in the soil at depth Z, okay? C is at depth Z from the beginning of the soil. And of course let us take the point D at the end of that. This is just a filter that will allow water to go through without allowing soil to go through, okay? So this is a filter. It is closed here. So all the area from here up to here, we have water, right? Because it's closed. So we have submerged soil, right? We have saturated soil, right? Okay? Now, we will have, let us say that we put a piezometer in at point B. This is piezometer at point B. How high the water will rise? Right? The water will rise to the same level, right? Point B can hold water up to H1, then it will be up to H1. What about at point C? To the same level. You know that water should be at the same level. At point D, okay? So here we have water will be at the same level. This condition is constant. It's stable, it's no seepage, as if we put this is 100 years ago, so water level will be at the same points, right? Okay. Now, what we need to do is to draw or to find sigma, which is equals to sigma prime plus u, okay? And I prefer always to solve this type of questions like this. We draw near it and we answer it by drawing, okay? Okay, at point A, what is sigma? 0. Why? Because there is no pressure above A. Okay, so sigma is 0. At point A, sigma is 0. What about U, poor water pressure? Why 0? Poor water pressure, we have to remember, poor water pressure is the height of water above that point multiplied by unit weight of water. So, no water, then this is 0. What about sigma prime? The height of submerged soil above that point.
0.
And even if I don't know, I know that 0 equals to 0 plus, so this should be 0. Right? Because 0 equals to 0 plus 0. Right? So this is, I can calculate it, or even always I subtract U from sigma. So at point A, I have 3 zeros. Sigma total 0. Poor water pressure 0. Sigma effective 0. Let us go to point B. What is point B? The end of the water, right? At depth H1. What about sigma? H1 gamma water. I have a stress here. So this is H1 gamma water. This is the pressure that I have at point B. H1 gamma water. What about poor water pressure?
H1 gamma.
H1 gamma water. Because the height of, so it's always H1 gamma water. So what will be sigma prime?
0.
Because H1 gamma water should equals to H1 gamma water plus 0. So this is 0. And I can understand this because sigma effective is the height of the submerged water above that point, and there is no submerged soil above that point. Now let us go to the point C at depth Z. What is sigma? H1 gamma water plus Z gamma saturated, because the soil here is saturated. Good. So it will be H1 gamma water plus Z gamma saturated. That's right. H1 gamma water plus Z gamma saturated. What will be the poor water pressure? H1 gamma water plus Z في gamma water. صح ولا لا? Then it's H1 plus Z gamma water. Okay. What is sigma prime? Don't tell me. I don't want to know. But I want to calculate it. Isn't it the difference between this and that? Okay, so let us do it. H1 gamma water plus Z gamma saturated, right? Minus H1 gamma water, right? Minus Z gamma water, right? Now, look. H1 gamma water minus H1 gamma water, right? So what do I have? Z gamma saturated minus Z gamma water. Isn't it this? Z gamma saturated minus gamma water. And what is gamma saturated minus gamma water? Huh? It's Z gamma prime, right? Z gamma effective, right? So this will be Z gamma effective. And I can know this because I always know that effective stress is the height of the submerged soil multiplied by gamma effective, right? So the height is Z multiplied by gamma effective. So in both directions it's correct. Okay? Let us continue to D. 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 What is D? H1 gamma water. Gamma saturated. Good. H1 gamma water plus H2 gamma saturated. What about U?
And the H1 is 2.
H1
2 gamma.
plus H2
Gamma.
gamma water. By the way, in the water, it's always linear. Why? Because the only change is the height, right? Okay. Now, let us find by mathematics, okay, what will be the difference here? It will be H1 gamma water plus H2 gamma saturated minus H1 gamma water minus H2 gamma water. Then it will be H2 gamma saturated minus gamma water. Okay. So it will be H2 gamma effective. Okay? You see? So I draw the pressure diagram that shows the stresses, total, effective, and pure water pressure due to this condition. Okay? Now, I want you to take a page like this page, for example, a page like this page, and write at the first line, no seepage, okay? Then take 1/3 of the page and draw this drawing, because we want to repeat it twice again, okay? So we need to make the other one and 1/3, the third one is what the third, okay? We need to have 3 drawings at this page to compare between them. So please, just take a line and draw at 1/3 of the page, and leave a space for another 2 lines with another 2/3 of the page. You can draw all this. Okay. I wrote here stresses at every point. You see, at A, sigma equals 0, sigma prime 0, U equals 0 at P, sigma equals H1 multiplied by gamma water, sigma prime 0, and U H1 multiplied by gamma water, right? At C, H1 multiplied by gamma water plus Z gamma saturated, Q Z gamma effective, and gamma water. And then at D, sigma equals H1 gamma water plus H2 gamma saturated, gamma effective, and this is multiplied by gamma water, right? We already put this on the drawing, okay? So this is the condition, the first condition. Now the second condition is downward seepage, which means that the same drawing, here I have, as you see, water, the same thing, H1, and soil, H2. At depth Z, I have point C, and this is D, and this is B, and this is A. What's the difference? I open the valve here, you see? Once I open the valve, water will go through, right? Will flow out, right? So I put additional water here to keep this at this distance, okay? So what do I have? I have downward flow, downward seepage. Water will go from up and down, then it will go out. Now, what is the difference between this case and that case? If we put piezometer at point B, how high the water will be risen here? Right? Because if B can hold the water more than H1, it will make it. By the way, this H1 is different than H1 in the previous question. Okay? It's different. So H1, whatever, that height, point B can hold water to the height of H1. So if I put a piezometer in B1, it will hold it to H1. H1 is different than that H1. Don't keep it just once in mind. But after that, if I put a piezometer in C, it will go less than. Why less than? And if I put it on D, it will go because of the flow. It's exactly as, you see, you can hold 100 kilogram, right? You can hold 100 kilogram. If I gave you 150 kilogram, you cannot hold them, right? So as if you are going down because you have more pressure from upside, right? So point C cannot hold only this height because there is additional pressure on it. So it will hold less than that height, okay? And at point D, still less because the height is more and more, right? So it will hold less than that. Now, suppose this distance, okay, I named it H small. So what is this distance? What is the distance between 0 and H? 0 and H, right? The change will be, point B will represent the 0, right? Point D will represent the H, right? Any point between B and D will be between 0 and H, right? Right? Let me explain it in Arabic again. إذا كانت النقطة B بتعطيني الارتفاع على هاي المنطقة، خلينا أعتبر إنه هاي نقطة الصفر، كويس؟ فB بترفع للنقطة صفر، D بترفع للنقطة قديش فرق؟ الفرق H، صح ولا لا؟ اعتبرته H. إذا أي نقطة بين B و D هتعطيني إحداثيات بين الصفر وبين H. واضح؟ بين الصفر وبين H. كويس؟ طيب والتغيير حيكون ماله لينير، صح؟ التغيير حيكون لينير. مظبوط، لأنه كل الفرق هو إيه؟ في الارتفاع. التغيير حيكون لينير. قديش قيمة هذا التغيير؟ لاحظ أنا بحكي عن فرق الليفل على طول إيش؟ المسافة. فرق الليفل من هون لهون على طول المسافة اللي قطعها من هون لهون، صح؟ مش هيك؟ يعني ال شو بتساوي في هاي الحالة؟ لا، ال بتساوي H2 ال لحالها. بس دلتا اتش شو بتساوي؟ طيب فرق الليفل على H2 شو هي هاي بنساويها؟ مش هي هاي الهيدروليك جريدينت اللي حكينا عنها؟ اي زد. على كل ان الحصة الجاي ان شاء الله بوضح لكم اياها بطريقة افضل. نكمل الحصة الجاية. يعطيكم العافية.